Hi, my name is Megan Leibensperger, and this is my presentation over the physics in the video game monkey cliff diving. So what monkey cliff diving is, you have 5 different heights, and you have 3 different types of monkeys. An anti-gravity monkey, a monkey that is affected by wind, and a normal monkey. In the game, you press on the screen on the monkey to have it jump, and the whole point is to have it land safely in the water. You have to time it accurately though, because the waves are rolling, and if you time it wrong, the monkey will hit the stone and it will die. And here is a quick demonstration of the game. The game is from addictinggames.com. So you click on the monkey, and it jumps up, and you land safely in the water. However, for our purpose, we decided to test acceleration due to gravity. So we were actually timing to get the monkeys to hit the rock so that there would be a consistent height. So we click it, jump, time it for it to hit the rocks. So we observe that jumping is a parabolic motion, and there is velocities in the x and y direction. However, we've focused on the y direction, and we ignored x because the monkeys we used did not go any direction except up and straight down. Because it's a parabolic motion, we know that the velocity at the top of the maximum height is 0. So therefore, we use that to have a 0 initial velocity. So we use a combination of Newton's second law and the universal law of gravity to find an acceleration due to gravity. We use sources from Tutor Vista and our textbook and notes. So Newton's second law is force equals mass times gravity, and the universal law of gravity states that force equals g, the constant 6.67 times 10 to the negative 11, times the mass of the object and the mass of the planet, all divided by the radius squared of the planet. So we set those equal to each other, and we solved for g, or gravity, to get the constant times the mass of the planet, all divided by the radius squared of the planet. And when you solve for that on Earth, acceleration is negative 9.8 meters per second. So we measured the height of the monkey on the screen, which was 0.01 meters, or 1 centimeter. And we divided that by the actual height of a chimpanzee, which is about 1.2 meters, to get a scale factor of 120 meters. Then we measured the height of the on-screen cliffs from 3 different heights, the bottom, the middle, and the top. And we multiplied those by the scale factor to get the height of the cliff. And then we timed the cliff plus 1 centimeter to get it from the top of its height. So from where the velocity is 0 to the bottom, we timed for that to get the total time. So we knew that the initial height, here's our sample calculations, for the top was 0.095 meters. We multiplied that by 120 to get 11.4, and the time it took from the top of its ball to the bottom was 0.8 seconds. So our original equation, we used the first kinematics equation of initial position final position equals initial position plus velocity times time, the initial velocity, times 1/2 of the acceleration times the time squared. We knew that the final position and the initial velocity were both 0, so those canceled out. And we solved for acceleration to get acceleration is -2 times the initial position, all divided by the time squared. So for this position, we solved using -2 times 11.4, all divided by 0.8 squared, to get a acceleration due to gravity of -35.6 meters per second squared. So from the 3 different heights, our chart shows that we found accelerations of -35.6 meters per second squared, -41.92 meters per second squared, -64.81 meters per second squared, for an average of -47.44 meters per second squared. This is way off the accepted value of -9.8 meters per second, showing that the game did not follow the laws of physics. So our results disagree with the laws of physics. They are not equal. We calculated the percent error using the average acceleration to get a percent error of 71%. So this game does not follow the laws of physics by any means whatsoever. So in conclusion, they did not use the laws of physics. However, we did not believe it retracted from the game because they were falling at a faster speed. It made it harder to time it accurately. So it added to the fun of the game and the difficulty. And if they had followed the laws of physics, it would actually be a much easier game. And these are our sources. Does anybody have any questions?